Hi guys, 4Tutor here. And before I start this video, which for reference is going to be me revisiting quadratic equations, this is not going to be Alg 1, this is Alg 2. I just want to say I'm proud to say that I am starting an Algebra 2 workshop class. So you can register with us on our website. I'll put the website link in the description. And yeah, you can join this Algebra 2 workshop. This is mainly for people who want to learn Algebra 2 or taking it in school. So I will be going over some of the most important topics in Algebra 2, and this is going to be one of it because I think it's extremely important that you revisit quadratics. All right, now that that's out of the way, let me get started. If you're watching this, I'm mostly sure that you guys already know what quadratics are because I'm revisiting them. You should know this already. However, for that one person who doesn't and is just randomly clicked on this video because it appeared on their recommendation feed, I am going to just quickly explain what a quadratic is. So a quadratic, or a quadratic equation, mind you, is any equation in the form of ax squared plus bx plus c equals 0. So a cannot be 0. If a is 0, that means that it would basically just be a linear equation because it's bx plus c equals 0. So they work like any other equation, however, they can actually have multiple solutions. Unlike, say, linear equations, which can only have one solution, quadratic equations can have up to two. That I'm going to prove in a future video. Subscribe for that, about me talking about the fundamental theorem of algebra. Yeah, that one. Alright. So that's what a basic quadratic is. And if a quadratic graph, if you graph a quadratic, it looks a lot like this weird parabola I'm trying to graph. My God. Yeah, it looks like a parabola. Basically just like a U-shaped thing. Oh, oops. Yeah, like this. It should look a little like that. Yeah, something like this. Okay, sorry. These like virtual tools are just weird. So now that we've gotten the quadratic stuff out of the way, well, Aarit, what do you want to revisit? I thought I learned everything about quadratics. Yeah, no. Remember that quadratic formula little thing that you supposedly memorized? Well, there's another hidden detail in there. Remember the quadratic formula is negative b plus or minus. I'm just going to do that. I'm too lazy to put the thing. Square root of b squared minus 4ac all over 2a. This is how to find the one or two or even no roots of a quadratic equation. It's one of the most basic ways. However, see this little b squared minus 4ac term here? This thing is called the discriminant. So I'm going to call it b squared minus 4ac is called the discriminant because it discriminates how many roots a quadratic can have. If I'm just going to be referring to discriminant as d. If d is greater than 0, then it has two real roots, meaning that it intersects the x-axis at two places. Because, well, the square root of a positive, there's two square roots of positive numbers. There's a positive square root and a negative square root. However, if d equals 0, then there is one real root. There's only one real root. There's supposed to be two roots, but like it's repeated. This only happens when the quadratic is a perfect square trinomial. Because remember, for a perfect square trinomial, b squared minus 4ac is equal to 0. However, if d is less than 0, then there are two imaginary roots. There's no real solution. They're all imaginary. I'm not going to explain what imaginary numbers are. I'm going to explain that in a future video, which again, subscribe for that. Yeah, but you should know that if d is less than 0, that means there are no real solutions. However, let's take a quadratic. I'm just gonna take the quadratic x squared minus 6x plus 10 equals 0. Now, what you could do to find how many roots a thing has is you could just substitute it in the quadratic formula. But we mathematicians, we're kind of lazy, you know. We just want a simpler way. So again, you could use the discriminant here. You can use the discriminant to find how many real roots or imaginary roots a quadratic has. Remember, not going over imaginary numbers. Way too complicated to fit in one video with this. Okay, so let's take the discriminant. So first you want to square b. So 6 squared equals 36 minus 4 times 1, which is a, times 10, which is c. Now check that. That's 36 minus 40, which is negative 4. Since negative 4 is obviously less than 0, so that means that this equation must have it must have two imaginary roots. And however, if we were to take another equation, we can just do x squared minus 6x plus 9 equals 0. It'll still be 36, but instead it's going to be 4 times 1 times 9, which would be 36 minus 36. And then that would equal 0. So this is an example of a perfect square trinomial. This is a perfect square trinomial that has only one real root. It's repeated. It's actually just like x minus 6 whole squared. It just has one root, but it's repeated. And let's take a last quadratic to illustrate the differences of the discriminant and how it impacts the roots. Let's just take x squared minus 6x plus 8 equals 0. This time it's going to be still 36 minus 4 times 1 times 8, which is going to be 32. So it's 36 minus 32 equals 4. That means that this equation has two real roots because d is greater than 0. I hope my examples have illustrated like how much of an impact discriminant has. And a discriminant is an extremely helpful tool. If you don't want to solve it and you just want to find out if it's like what kind of roots are there, like are they real or imaginary, just use the discriminant. You don't need to substitute it into the quadratic formula. I guess that's it then. Thank you for watching. If you're interested in joining our Algebra 2 workshop classes, register in our website. I'll put the link in the description right now. And also, don't forget, I forgot to mention this earlier, but if you like my Spanish content, I'm going to start a Spanish 2 workshop. I'm basically done with Spanish 2, so I have no reason to like try on it whatsoever. But I wanted to educate you guys who like maybe are taking Spanish 2 next year or just want to learn Spanish 2 because you're good with Spanish 1. I want to educate you guys on those topics. Just for a quick summary, I will be covering preterites in that workshop. I'll be covering preterites, imperfect tenses, like maybe some basic impersonal stuff. I'm gonna put all this in the I'm not gonna explain everything. However, for my Algebra 2 workshop, I will explain everything. In our Algebra 2 workshop, we're going to be covering this, quadratic equations, and then we're going to go straight into imaginary numbers. Because imaginary numbers should be learned as soon as you learn quadratics. Because you're gonna have a lot of confusion. Like for example, if you encounter a quadratic like x squared minus 6x plus 10, you won't know how to solve it. You'll just say no solution. The real answer is no real solution because there's two imaginary solutions. That's at least my opinion, though. After quadratics, we're probably going to go into polynomials. Extremely crucial, very helpful, must be learned. And then we're going to dive into radical and rational functions. These two are extremely critical for Algebra 2 mastery, but they can get a little complicated, don't worry. And then there's conic sections. They're There are seven conic sections, but we're only going to go over four: the circle, the ellipse, the hyperbola, and parabola. And then our last couple of units, we're going to be talking about sequences and series, and then trigonometry, which is like trig graphs, radians. Oh, and by the way, speaking of radians, if you haven't watched my video on how the unit circle is so impactful, you should go watch that right now. God, change. Yeah, you should go watch that video on how I made on how the unit circle is so important. It's super, it's great. I actually gave it in the presentation. And I guess that's it, actually. So thank you for watching. And don't forget to join our Algebra 2 workshop sessions. All right, this is Aarit signing off.